In binaries, there's nothing called parent class and subclass. It's all binary. There's no differentiation. So this is for our understanding and the better structure of our code. Okay? So essentially, on the code level, they're just binary strings. All right? Then, as you are going through this, you may say, oh, actually, to be honest, this is already a system you can implement. No problem. You can implement that way. Then, you with more experience doing this, you may say, okay, all right. So button don't directly communicate with elevators. We need additional class, which are control class, which is basically a better system structure. Instead of having directly talk to the elevator, you actually have an elevator being controlled by a controller, which is a typical computer control system. You have input, you have controller, and you have things that need control. Okay. What are the entity classes here? What are the entity classes here? What information is being kept here to you? For that elevator sitting there, you may say, that's a mechanical device. Guess what? Just like this one, it has a computer inside. Actually, a fairly complicated computer. What is that computer memorizing?
The floor? Which floor it's on?
Yeah. It's actually remember right now which floor that thing is right now.
Maybe the button light?
Button light, absolutely need to keep. Okay? So those are information, that's why buttons, controllers, and elevator, all these are entity class as well. This information, this can be actually an input class, the boundary class at the same time. Dubbed as both entity class and boundary class, because your computer system, that system actually keep a lot of information, right? So for instance, it has two elevators, need to know where the two elevator is. The button light status of each button inside the elevator. Okay, it's actually running a complex algorithm called elevator algorithm. I don't know how many of you have learned about that algorithm before. There's actually a famous algorithm called elevator algorithm in your algorithm book. Basically, so this is whenever you're sitting there and just wondering why is the elevator not coming to me. Okay, because somebody actually coded the elevator algorithm which regulates how elevator go to a certain floor. Okay, you may see actually elevator passing you, not stopping on your level. Why is that?
It's not going the way you want to go.
It's not going the way you want to go. It's actually maybe so. For instance, if somebody is calling the elevator on fifth floor, you are actually on the third floor. You're calling the elevator as well. The elevator pass you by to the fifth floor and come down. Okay. So for instance, if you are to just give you an example. Right now, the elevator is in first floor. If you are on the third floor, calling for the elevator, you push a button. The elevator started on the first floor. Then he actually on fifth floor push the button before the elevator reach you. And high likelihood, the elevator will pass you by, go directly to fifth floor, pick him up, go down to third floor, then go down. If both of you guys want to go down, right? So actually, those classes this controller need to calculate that. This controller need to retrieve information from elevator, from floor, from all its buttons. Okay, that is actually the control system over there. What information is this guy keeping? It actually keeps information. What is this box? down box actually keep.
Need to switch it?
It has to, right? If I say this, it need to remember what is going on, right? Otherwise, it's confused. I will be confused, right? Right now, I say it's actually mute is on. It mute should be on, right? If now I push it again, should unmute. That information need to be kept. So it's not say the information say okay it has to live forever. That transit information for me is the information that need to be kept. If nobody toggle it, it should be there for a long time. All right. Also, there are CRC cards. Basically, this is a way to. We'll talk about this a little later. Essentially, it's a way for you to assign functionality to your class. Okay. So another thing to think about is, okay, not only you have to look at. This is called static model. This is just say, what are the things you have in your system? Okay, so this is essentially the first level hierarchy of your system. All right? If your team member is capable of programming this whole class, then in terms of partition, that's the granularity you should go to. Why? Because he or she can easily take care of this problem, this class. He or she can take care of. Then this is the level of partition you should stop. Don't go any further. Let him or her do the job. That's how you decide how detailed should your partition be. Okay? This static model means that we need to have this class, that class, and all these classes in our system. Actually, I go inside your code, I can find these classes. I go inside your code, I should be able to find these classes. Okay? That is static information, static structure of your code. I need to find elevator class, control class, elevator button class, floor button class. If you really want to go fancy, you have a parent class called button. But that's just for fancy. Make your code read better, make your concept better, but it's not necessary. Okay? Just the efficiency improvement, readability improvement, but it's not something you need to survive. The other side of your program, when it's really running, okay? When I go into your code and look at your code, I say, oh, I need to find those 4 classes. I'm actually not seeing your code is not running, okay? Your code just sitting there for me to read. So I can see the structure. However, actually, this is typically any program would have this called state machine. Okay, this is the core of our discipline, state machine. This is how we actually, our computer can work as it is today. Your computer is a big state machine. Look, this is your computer, okay? This is actually, we say it's an elevator because the problem we're trying to solve is the elevator. However, this is also your computer. Once you push your power button, your system boot into something called an event loop. Okay? Where that is that state? This state is right here. We forgot about login, okay? Just suppose that login is, we forgot login. So if you push a power button on this computer comes to here on this screen. That is actually your event loop. Okay? Basically, all the program behave this way, almost. Then, if I push on a button, I'm actually driving the system down to a different state. If I escape, it goes back to the original event loop. If I click on this, I drive this into the state with that recycle bin open. If I go click on this recycle bin, kill it, I go back to the event cycle loop. Okay? All operating systems behave exactly like this. You put your system into an event loop state, it's basically taking your input to do things. Okay? All computer systems. Your server, same way. Okay? Don't underestimate the power of this state machine. This is basically every program, meaningful program, behave this way. Okay? Replace this with something called Facebook server. All right? It works the same way. I send a message to Facebook, say I want to log in. They send back a message to me and say, sorry, you're not authorized. Okay. I try again. I send the real username and password. I send back and say, here, you're welcome to log. You're in. It's give you the information back, the event loop. Okay. Then I send in, so click on something, I get some information back. Okay. Basically, the Facebook, the server is an event loop ready to process your information, process your request. Every time you're talking to Facebook, you are actually sending a so-called HTTP request to Facebook server to get back something to display. Then the server go back to waiting state, waiting for you to send yet another HTTP request. Exactly the same thing happened with our elevator. Once the elevator is booted, it's going to this event loop. Then when something happens, it do something and come back to the event loop. Okay? This is state machine. This is how we track what can be done in the system and how things happen within our system. Okay? So this is exactly the things happen. People always call this as black magic. When people don't understand how computer program works and how computer works, you say, oh, this just magically happened. No, not magically happened. Somebody like you programmed the event loop just like this. Okay? And this is your computation, the things that are going on in your system. All right? So that's why I think now you probably recall in some of your class discussion and group study, you probably have drawn same machine like this. First stage, second stage, we go back to the same stage. Yeah. Basically here is, okay, when button push, button turn off, process new request, then go back. Right? Either moving in direction D and floor F is next, do something, process. Basically this is, when something happens, the system needs to react to that request. Same thing with Facebook. You send a request to Facebook, it gives you back some information. You send another request, it gives you back some information. Just so that you are clicking on an image, you're clicking on a video, you're clicking on sending a message, okay? That's just different command, encoded as HTTP request. All right? We'll talk more about this later. So this will be, so this is essentially how you show dynamic behavior of your system. So I'm going to stop here and we'll continue next time. But key thing here is, as we transition into the term, we are also gradually transitioning into from outside our system into inside our system. When we talk about detailed design, we're all the way actually transit into how exactly that elevator algorithm is implemented. Right now, I'm just happy with say, okay, the algorithm has the elevator has an algorithm to decide. That's it. But when I go to detailed design, that's the time I really need to be clear how exactly I'm going to write down that algorithm. Just like how you guys are going to write down a stack class and that kind of thing. Right? That's a detail level. But just keep in mind, we start with basically outside of the system. Then right now we are taking in a step into the system, see what are the higher level components we need to have in the system to make it work. In the worst case, we can always use our elementary school and middle school skill set to actually analyze the text, to get all the nouns, and trying to put them in the right place, either going to be a class or attributes or nothing, right? But we are not throwing them away just in case we're coming back to them, right? Then next time we're going to assign attribute to classes, assign actions to classes, to assign methods to classes. Where does that method come from? It's actually from the dynamic behavior that you created here. That's that, like your behavior of your system. Okay? Then we can, once we have the class defined, attribute defined, then we can pick the algorithm. Once the algorithm picked, boom, it's actually on you guys' level. Okay? Once given an algorithm, I'm saying you should implement this algorithm, depth first search on the tree, you guys know how to do it. All right? All right, let's see what quiz we have today. I think it's going to be related to stack as well. Okay, I wonder if anybody wants to use that opportunity to write the code on the board. I'm going to make this as a volunteer opportunity. So if you would like to just get the feeling of how the difference of writing code on board or writing code on your piece of paper or into your IDE, you can try to use the one on board. Okay, here something interesting. All right. How many of you have finished your linked list implementation? I hope so, because it's needed here. Here I'm going to ask you, say, I'm tired of your traditional stack implementation. I want you to implement your stack with your list. How would this work? Right? Stack is stack, right? And first in, last out. List is different. First in, first out. Right? But I'm just being difficult today, right? I ask you to re-implement your stack with the linked list you implemented last week. This is a true interview question. Okay? How should we do this? You have your linked list. How to implement your stack with this linked list. Basically, what I'm saying is you are call on your linked list class. Go ahead.
Well, yeah, you keep using different words for things.
Okay.
What's the actual thing we're supposed to be doing?
Queue is a specialized version of linked list, right? So queue, you're not supposed to manipulate things in the middle, right? Linked list, I can say, go delete the fifth one in the list, right? That's a, so but Q I can only say you in Q or DQ. That's the difference. So you're right. So Q is actually a more specific form of list.
So, do you want us to implement a stack using a queue or a queue? Because the actual text of the quiz says.
Okay. I must be confused with two of my questions. I'm sorry, I take that back. This will make your life a little bit easier, okay? So yeah, so here we are going to, so I think I confused with two of my questions. Oh, I'm going to change my question next time. So you guys don't know what is coming up. Okay. Here, it's going to be a real question, okay? So now we have stacks from last time, okay? Stacks last time. So I'm going to be difficult and say you cannot use linked list as your base case for your queue. Now, it's basically what the only data structure you have available to implement in your queue structure are your stacks from last time. So the difference between queue and stack is very obvious. Stack is first in, last out. Stack. Right? You push, 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 push.
Last in.
You pow, 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 pow.
Last
Last
in,
in, first out.
Last in, first out, first in, last out. Okay? Your queue is first in, first out. Last in, last out. Right? Queue. So so for instance, if we go to a grocery store, we're in the checkout line, and that's a queue. Hopefully it's not a stack, right? So the queue is, okay, you are ahead of me, then you should get checked out first. Sometimes it doesn't happen that way, right? But stack is different. Stack is you are on, so if you get there early, sorry, you're actually going to be the last one go. So here, last time, we have you implement a stack, right? Now I want you to, so based